I want to thank the organizers of World of Group Craft 2 for giving me this opportunity. In this talk, we will see a combination theorem for spaces of triggered spaces. First, we define the terminology used in this work, and then we state the combination theorem. A triggered space B is a complete geodesic metric space which can be decomposed as a collection of geodesic subspace script P, and each element of this script P we call as pieces satisfying these two conditions. Any two distinct pieces will have at most one point in common, and each simple geodesic triangle in B has to contain in a single piece. And in this talk, by a triggered space B, we mean a complete geodesic metric space along with a one-ellipsis surjective map pi t onto a tree capital T, such that inverse image of any vertex U is a geodesic subspace, and inverse image of an edge has isometric embedding under pi t onto the corresponding edge inside the T. And now we define a space over this capital B as our spaces of triggered space in the next slide. So X is a geodesic metric space and B is a triggered space over a tree capital T. F is a proper map. That means inverse image of any compact set is compact, and C is greater than or equal to 1. A space of triggered space capital I mean script X, that is some map from pi b from X to B, consists of this following data. So pi b and pi t compose pi b, these are one ellipsis surjective maps, and for each vertex u inside capital T, and for all a inside the corresponding piece bu, the inverse image of a under pi b is a geodesic metric space, and we denote this space as f a comma u, and we call this space as fiber. And we also want that the inclusion map from this fiber to X is a proper embedding. That means any 2 points over inside this fiber which are at most r distance apart inside X, they are at most fr distance apart in the fiber distance. And the third condition is that for all vertex u inside T, suppose a1 and a2 are points inside the corresponding piece bu which are one distance apart, and let alpha is a geodesic joining a1 and a2. Now for all a inside alpha and every point x inside the fiber over a, that can be joined by a path of length at most c to a point inside the fiber over AIs, and this path lie inside the inverse image of alpha. And this is the last condition, is that for any edge v comma w inside T, from the structure we have a unique edge cv comma cw joining these pieces vv comma pw, and we want that evw, that is the inverse image of midpoint of this edge cv comma cw, that is a geodesic metric space, and we call this space as our H space. And we also want a proper embedding from this Cartesian product. This is of length 1, I mean CV comma CW, this is of length 1, and we have a proper embedding from this Cartesian product to X, and this is the structure for spaces of triggered spaces. So here we have a picture. So this space is X, and this is a triggered space B, and below we have a tree. So this is the structure for spaces of triggered spaces. And we also have graph analog, that where capital X and B, these are all metric graphs. So we leave for this talk and we refer the paper for more details. Now we define uniform flaring. So suppose this pi b x to b, this is a spaces of triggered space, and we say it satisfies the uniform k flaring where k is greater than or equal to 1 if there exists mk greater than 0, such that for all d greater than or equal to 0 we have a constant tau satisfying this following. Before that, let me define qi lift. So suppose we have a geodesic from 0 r interval inside r to ab inside b, that is a joining, I mean this is a geodesic joining a and b, then a kqi lift, say gamma tilde of this gamma, is a k quasi isometric embedding of this interval 0 r inside capital X, such that, so here we have three maps, gamma from these to ab, and we have gamma tilde from 0 r to capital X, and pi b is a map from X to b. So such that this diagram is commutative. So this is the KQI ellipse. So now come back to uniform flaring. So what is that property? So is the property is that for every pair gamma naught and gamma 1 of KQI ellipse of a geodesic gamma joining A and B, such that the fiber distance of gamma naught Ri and gamma 1 Ri is greater than Mk, where Ri's form a partition of the interval 0 R, such that consecutive points will have at most one distance, and we are assuming that the fiber distance of the images of n points under gamma naught and gamma 1, they are bounded by d. Then we can bound r in terms of tau. This is the uniform flaring condition. And so now let me state the main theorem. So suppose this pi b x to be this is a spaces of triggered spaces over this b, where b is a triggered space over t, such that the fibers are all uniformly hyperbolic geodesic metric space, and the Gromov boundary of this fiber consists of at least 3 points. Then we have a barycenter map, and we are assuming that these barycenter maps are uniformly coarsely surjective. And second condition is that the A proper embeddings from the H space to the corresponding fibers, these are all, we are assuming that uniformly quasi-isometric embeddings. Third condition is that pieces are all uniformly hyperbolic geodesic metric space, and it satisfies uniform K flaring for a large enough K. Then X is hyperbolic geodesic metric space. And now we have a general result on the necessity of uniform flaring. It says that suppose we have a spaces of triggered space x over b, and b is a triggered space over t, then such that the x is hyperbolic, then it satisfies a uniform K flaring. So in this proposition we don't require any technical condition which are used in the main theorem. So now this is an application in groups. So G comma Y, this is a developable complex of non-elementary hyperbolic groups over a finite connected simplicial complex Y, satisfying a weak QI condition, and let G is a fundamental group. G is the fundamental group of these complexes of group, such that the local monomorphisms are QI embeddings, and the development corresponding to the inclusion morphisms is hyperbolic, and it satisfies a uniform flaring. Then G is hyperbolic. And as a corollary of that proposition, we have this, that suppose this is a developable complex of finitely generated groups over a finite connected simplicial complex Y, such that the fundamental group G of this these complexes of group is hyperbolic, then it satisfies a uniform flaring. So this talk is based on this preprint, a combination theorem for spaces of triggered space, and here are some references. Thank you.